So two students investigated how the acceleration of a trolley depends on the force applied. So in any investigation we do in science, we'll have a independent variable and a dependent variable. And then we will test the relationship between two variables. So we will be changing one that will be independent, and then in order to find out the impact on other one, we will be measuring something, so that is the dependent variable. Everything else has to be kept the same in order to keep it a fair test. So in this one we are investigating the relationship between acceleration and the force, net force. So what they are going to do, they are going to change the force, varying the force. That's going to be our independent variable, and then they're going to measure the acceleration, so that's going to be our dependent variable. So before starting the investigation, each student wrote a hypothesis. So before they are finding out what is the actual relationship between acceleration and force, they are writing a hypothesis, making a logical conclusion statement. So acceleration, student A says acceleration of the trolley is directly proportional to the force applied. So acceleration is directly proportional to the force applied. Student B says changing the force applied to the trolley will change the acceleration of the trolley. Okay. Consider the hypothesis of student A predicts what would happen to the acceleration of the trolley if the forces applied to the trolley is double. So remember, if we have a directly proportional relationship, we will have a straight line through the origin. Every time you double one quantity, the other quantity, other variable is also going to double. If you times that by 4, it is also going to increase by the same rate. That is what directly proportional mean. So what will happen, acceleration of the trolley, if the force applied to the trolley is double, if the force applied to the trolley is double, the acceleration will also double. Okay. Why is it difficult to make a valid prediction using the hypothesis of student B? Okay, student B says changing the force applied to the trolley will change the acceleration of the trolley. So they didn't say they are changed. In science, you should be more precise. You need to say whether it's increasing or decreasing. So the statement does not specify whether the force increasing or decreasing will cause the acceleration to increase or decrease. So they didn't actually say it's, they just said change. So change is not good enough. They need to say increasing the force will also increasing the acceleration, or increasing the force will decrease the acceleration, or decreasing the force. So they need to be more specific on this. Okay. So figure 1 shows some of the experiment used by the students. So they have a sloping runway and a trolley. Okay, so write a list of any other equipment the student will need to complete the investigation. So what else they need? They need a timer, because they need to measure the acceleration. So acceleration, they need to use timer. Why? So acceleration, what is acceleration? Acceleration is the rate of change of velocity, how fast the velocity is changing. So velocity divided by time. So how would they calculate the velocity? So velocity is distance or displacement divided by time. So what they need to use to measure the displacement, which is a length, so they need to use a meter ruler. Time, they need a stopwatch or timer. So, and force, what they can use, Newton meter. So they could use Newton meter to measure the force. They could use a meter ruler to measure the displacement, and stopwatch or timer. Okay. And also in this setup they don't need this, but if they keep the trolley in a flat surface, what they can do is they can have a pulley, a string, and a stack of masses. So they could just a pulley, a string, a stack of masses. So they could use this one as well. Right. Why should the student use a sloping runway? So why did they use the sloping runway? To reduce the effect of friction on the trolley, to decrease the acceleration of the trolley, to stop the trolley rolling back up the runway. So they use that for that. So friction, if they have to reduce the friction, they will have to use air drag. So that means, so they will keep the trolley levitating, so that there is no contact, so there is no friction, because friction is a force when two surfaces are rub against each other, move against each other. So if we are using air drag, the object, the trolley, is going to be levitating and it's not going to be touching, then it's going to reduce the friction. But the reason why they are using the slope in this particular example is to stop the trolley rolling back on the runway. Okay. Right. So describe a method a student could use for their investigation. This is a 6-marker question. So what they can do, so you can do two ways. Either you can increase the height, varying the height of the slope. By that you can vary the force. That is quite hard to, you need to do a lot of calculation to prove that. So easier method for your specification is this one, this method. So you have a trolley, and then you have a pulley, and then attach a string, and you have a stack of mass here, and then you can have a light gates. So you can have light gates. So what you can do, arrange a trolley attached to a string on a horizontal drag. Okay, so you can do that. So add stack of mass at the end of the string through the pulley. So basically you are going to attach a string on a string to the trolley, and on the other end of the trolley you're going to have a stack of masses, and it should be going through a pulley. Okay, and what you're going to do, release the trolley, and make sure the stack of mass does not hit the floor when the trolley reaches the end. So what you have to make sure, when the trolley reaches here, the stack of mass shouldn't be hitting the ground floor, otherwise it would affect the net force that is applied on here. Okay, so what we are doing, we are arranging a trolley attached to a string, and on the other end of the string thread that string through a pulley, and at the other end of the string we're going to add some stack of masses, and we're going to release the trolley, and using the signal gate or light gate, calculate the change in velocity over time to find out the acceleration. So you need to say that acceleration is equal to change in velocity over time. So that's what they expect you to say in there. So you are using the light gate to calculate the velocity change over time to find out the acceleration. And then what you're going to do, remove 1 Newton force or 10 Newton force or stack of mass, and put it on top of the trolley and repeat step 3 to 4. So what they are doing, so once they done that, so first step was stack of mass, let's say they had 100 Newton put together. Now what they're going to do, remove one of these masses and put on top of this trolley. So now it's going to be 90 Newton. They're going to do it again and then repeat it till various, so 6, repeat the net force, repeat the practical for different set of net forces. Okay, so maybe 100 Newton first they can do, 90 Newton, then 80 Newton, 70 Newton, 60 Newton, 50 Newton. So they can do it for over a range of value, and then finally what they can do, plot the force, the net force against the acceleration. So plot the net force against acceleration graph. Okay, so if they do that, they would get a directly proportional curve. So if they do that, they will get this kind of relationship. So they change the force and measure the acceleration, so that will be directly proportional. Okay, so what they are doing, they are attaching a trolley on a horizontal, placing the trolley on a horizontal track and attach a string through a pulley, and on the other end of the string they're going to add a stack of mass, maybe 100 Newton, and then they're going to have install a light gate in between, and then release the trolley, and then using this formula, changing by using the light gate, they are going to measure the acceleration, but you need to mention acceleration is change in velocity over time. So using that, they are calculating the acceleration, and every time then afterwards, every time they are removing 10 Newton force from the stack of mass and placing it on top of the trolley in order to keep the total mass in the system same. And finally they will repeat it for different set of weights, and then they're going to plot a graph acceleration against force, and they should get this directly proportional relationship. Okay, so explain why hypothesis A give a better explanation of the result, because hypothesis A, again all over here, the student A say acceleration of the trolley is directly proportional to a force applied to the trolley. So that is better because result give a straight line and that pass through the origin. So the result if you can see, it's a straight line. It goes through 0, 0. So A is better explanation because the best fit line goes through, it's a straight line that goes through origin.